Hey everyone, and welcome to this explainer. Today, we're going to take a foundational, mathematical absolute, something you probably just accepted as an unbreakable law of the universe since you were a kid, and we're going to completely unravel it. We'll be diving into a really fascinating text by Feng titled Two Parallel Lines Intersect at One Point, and by blending theoretical physics, quantum mechanics, and some pretty deep philosophy, we are going to challenge the very fabric of how we perceive space, time, and honestly, reality itself. So let's just get right into it.
Okay, let's start with the core mystery here. Do two parallel lines ever actually intersect? Take a second to really think about it. It's one of those questions we all thought we confidently knew the answer to since, high school geometry class? You draw two perfectly straight lines, side by side, heading in the exact same direction. Our common sense, which has been heavily trained by traditional education, just screams the answer at us.
And that answer is no, never. Right? According to Euclid, the ancient father of geometry himself, this is an absolute impossibility. Euclid proved the parallel line postulate from the perspective of a two-dimensional plane. And it doesn't even stop there. Even when we scale things up into three-dimensional space, Euclid's postulate holds incredibly strong. It's considered an undeniable fact. Actually, the source text points out that even if we assume the multiverse theory found in quantum mechanics string theory is accurate, which is a wildly expansive concept of reality, even in that extreme scenario, two parallel straight lines simply cannot intersect at a single point. So the main takeaway here is that within this mathematical abstraction, the lines are never, ever going to cross. But, science didn't just stop with Euclid. And this is exactly where Albert Einstein enters the picture, brilliantly illustrating this tension between rigid geometry and gravity-warped space. Einstein, looking at things from the vast perspective of the cosmos, reasoned that massive objects actually cause space itself to deform and curve. When light travels and encounters an object with enough mass, gravity literally prevents it from traveling in a perfectly straight line. Because of this curvature, Einstein hypothesized that two parallel lines might actually intersect at some point. He basically suggested that Euclidean geometry might not be the universal, end-all, be-all principle we thought it was. But here is the catch. He never definitively provided the proof for how they intersect. And honestly, to this day, traditional scientists haven't been able to prove it either.
What's really fascinating is watching how other major scientific frameworks have tried and totally failed to solve this. Like, if you treat time as a one-dimensional construct, general relativity says time can deform. But if two lines are moving through time, they just deform simultaneously and stay parallel. What if you throw them into a black hole? Well, they might terminate together at a specific point, but terminating together doesn't mean they actually cross. Even the holographic theory of the universe leaves them on fixed parallel paths, positing that they carry the exact same information and are perfectly equal. Across all these accepted scientific frameworks, the outcome is exactly the same. The lines just remain stubbornly apart.
So to find our intersection, our source material turns to the elusive unified field theory of the universe. Now, mainstream scientists generally believe there are only four fundamental forces acting on reality: electromagnetic force, gravitational force, strong nuclear force, and weak nuclear force. But relying on just those four hasn't been enough to establish a complete unified field theory. However, if we look at the uncertainty principle of quantum mechanics, we realize that the physical state of fundamental particles, their wave-particle duality, is intimately connected to the observer's method of observation. And this leads to a massive leap. Some pioneering thinkers realize there is a profound missing link here. They realize that consciousness itself, or intent, is actually related to the movement of matter. They argue that you simply cannot have a complete unified field theory without factoring in the awe-inspiring force of consciousness. And incorporating consciousness, that requires us to completely rethink time. To understand how parallel lines can cross, we have to accept that our traditional concept of time is fundamentally incorrect. Enter the concept of lateral time. The illusion that time flows uniformly and in one direction, like just a vertical line from the past straight to the future, that simply doesn't align with reality. Time is actually a recorder of the motion state of matter. Because matter can annihilate instantaneously, essentially popping into another space-time, it leads to the creation of lateral time. So time isn't just a forward march, it actually has sideways or lateral properties depending on the speed, the mode of movement, and the space in which the matter exists.
Okay, let's map out exactly how this jump works. Say at 0 seconds, we have standard linear existence. Matter is moving forward predictably, doing its thing. But 10 seconds in, an annihilation event occurs. The matter instantaneously shifts. And this isn't just a stop, it's a leap. Just 1 second later, the matter has made a lateral space-time jump.
slipping sideways into a completely different temporal flow. Years later, its entire trajectory is completely new. This lateral jump is the absolute key to breaking the parallel line postulate.
To bring this abstract concept firmly down to earth, the author provides a brilliant, vivid analogy using two speeding trains. Imagine two trains speeding forward on perfectly parallel tracks. In normal 3D space, they obviously cannot collide. But suddenly, they are drawn into lateral space-time. Because the precise moment they enter this lateral time differs by just 1 single second, their trajectories experience a microscopic shift. And then, a collision. The lines intersect. The author compares this to a mirage phenomenon, where two distant scenes suddenly intersect and overlap just because of environmental conditions.
And this brings us to a really profound conclusion about Einstein's logic. As the text notes, and this is a great quote, "As long as there is distance in space, the forces acting on the two parallel lines cannot be equal." The author argues that if Einstein were still alive, he would inevitably come to this conclusion. Space isn't just some perfect empty void, it has planes of intersection. Even if our two parallel lines have the exact same mass and the exact same information, the simple fact that there is a physical distance between them in space guarantees that the complex forces acting upon them will be slightly unequal. Over time, those unequal forces will inevitably cause their trajectories to shift, forcing them to either separate entirely or, eventually, intersect.
Let's look at one final, very human scenario to see how consciousness and lateral time weave together. Picture two strangers sitting in parallel car seats in a moving vehicle. There are two parallel lines. Suddenly, a tragic accident occurs. One person dies, and the other survives. At this exact moment, they haven't physically intersected. Instead, the deceased is instantaneously drawn into lateral space-time. Years pass. The survivor, driven by that force of consciousness we discussed earlier, suddenly dreams of sitting in that exact empty seat. In that mental space, the parallel lines intersect. Alternatively, years later, the survivor also passes away, entering that exact same lateral space-time. They converge, becoming deeply connected in a new reality. It's a really profound way to show that rigid geometry just cannot account for the journey of consciousness through time.
Which leads us to the ultimate paradigm shift. The author's absolute conclusion is simply this: there are no parallel lines that do not intersect or separate. Rigid mathematical rules, while they're obviously incredibly useful for building bridges and passing geometry tests, eventually have to bend to the fluid, interconnected, unified nature of the actual universe. When you factor in the curvature of space, the unequal forces acting over any distance, the reality of lateral time jumps, and the undeniable force of consciousness, perpetual parallel movement is revealed to be nothing more than a theoretical illusion.
So, I really want to leave you with this provocative thought as we wrap up today's explainer. Where are the parallel lines in your own reality? What absolutes have you just accepted as unchangeable facts, simply because you haven't yet factored in the hidden forces of lateral time, human intent, or the inevitable curvature of life's trajectory? The universe is vastly more dynamic than a textbook diagram. Keep questioning those absolutes and stay curious about the hidden intersections waiting out there in the unified field of your own life. Thanks so much for learning with me today.